Yes.
Good. All right, so hello everyone. Yeah, my name is John Lundberg. I'm a product owner and architect for the Brain team. We work on on Griffeye Brain and on photo-DNA, similar images, and now robust video matching as well. And that's what I will be talking about during this last part of the last part of the day. Yeah. I will talk a bit about how the video signature works, try to explain that and give you an understanding of how it works, what the limitations are, so you know what to expect. I will talk a bit about how this is hosted together with CS, so that you can prepare for that. And finally, I will talk a bit about the features that we will bring to CS that utilizes the video matching. There will be a lot of information in the first slides. I'll do my best to explain them as well as I can, but if you have any questions, don't hesitate to raise your hand and I will try to answer them before moving on to the next slide. Yeah, so we have gone for a frame-based approach to do video matching, where each frame is hashed with a perceptual hashing algorithm. And the matching algorithm utilizes the PDQ hash, which is a perceptual hash similar to photo-DNA. The main advantages of the PDQ hash that we see is that matching is faster and the hash itself is also shorter, which means that it has a lower memory footprint on the service itself that does the matching, but also when you share hash sets with each other, which with photo-DNA would have grown a lot when it comes to signatures of videos. And the PDQ hash is also open source, which makes it easier for us and for others who would like to be able to match these signatures. The PDQ hash was developed a few years ago by Meta for content moderation in their platforms, for example, Facebook and Instagram. And another advantage of the PDQ hash is that we also get a quality metric, which helps us avoid problems that we have had with photo-DNA at times when it is applied to images that doesn't contain enough visually distinct content. So when we hash a video, we skip frames that does not have a high enough quality score to reduce the risk of false positives. That is when two frames match, even though the frames are not identical. So basically, each frame in the is hashed, and frames that have the same visual content are merged to scenes, and we use the PDQ hash to determine if they have the same visual content. And to be able to quickly match these video signatures, we put them into an index. And a lot of the research time has been working on that index, how to make that as fast as possible. Another way to improve the speed of the video matching is to keep the number of indexed hashes low. And therefore, we also reduce the number of scenes further before we index them. And keeping that number low also reduces the size of the video signatures that needs to be shared in the hash sets when we in the future want to match videos against GID. So when we reduce the amount of scenes that we index, we include scenes with a keyframe. Or if there is a large time between keyframes, we include one scene every 4th second. And keyframes, if you're not familiar with that, it's a feature of video compression, where a keyframe is encoded as a full image, and the frames in between keyframes are then encoded as the change from the previous frame. And in this example that I've tried to put together here, each color represents a number of frames that look the same. I apologize to anyone who has trouble perceiving different colors. And for simplicity in this example, each frame, it's just one frame per second. So KF indicates that the frame is a keyframe. LQ here on the purple frame indicates that the PDQ hash had a low quality score. So in this scenario, all the blue frames matched each other and were merged to one scene. The green and the yellow, they were visually distinct. So the scene has the same hash as the original frame. The red, gray, and orange are also merged to scenes. And when we then index the scenes, we would index the first scene, and the next scene we index is either the next scene that has a keyframe or the next scene that ends more than 4 seconds later, whichever comes first. So we would index the blue scene, and then the green scenes is that contain a keyframe. We would not index the yellow frame since the time between the green and the yellow frame wasn't enough, and the yellow frame wasn't a keyframe. So this green scene in the index would actually get to represent the entire video segment, including both the green and yellow scene. Yeah, the red scene would be indexed since it contained a keyframe, and the gray and orange would also be indexed since those more than 4 seconds had passed between those scenes. And the only time in the original video that isn't represented in the index is the parts that had a low quality hash. And the reason for that is that though that could go on for some time if there's, for example, a long chunk of the video that's just black, or yes, some other very low quality or low visual entropy content, and we don't want to mark such long periods of time as overlapping if we're not sure. So when we do the matching, we use all the scenes from the video. So all of these scenes would be queried against the index. So we would find, in this simple scenario, we would find each of the frames in the index. When we query with the yellow frame, we wouldn't find a match for that scene, but this green scene represented also that part. So we would still mark that as overlapping, and we would end up with a video match that's overlapping in all parts except this part with a low quality hash word. So the idea here is that a modified version of the video would get roughly the same scenes here, and therefore also find the reduced number of scenes in the index. So are there any questions before I move on to the next slide? Nothing in the chat, just yet at least. So this approach, as with any approach really, comes with some limitations, and the research has been a balancing act between speed and accuracy, and we of course want both to be as high as possible. Our first priority has been to not have any false positives, and this is mainly achieved by filtering the hashes on the PDQ hash quality score. The second priority has been to have at least one matching scene. If you have two matching videos, to get at least some overlap. That has been our second highest priority metric. And thirdly, of course, we want to make that overlap as high as possible when the videos match. But most improvements in matching speed comes with a slight loss of overlap for the average match. So one limitation with the approach right now is that there might be differences in the scenes that we don't index. We wouldn't get false positives between videos that don't match at all, but a certain part of the video might be marked as overlapping, even though there might be slight differences in the parts that we didn't index. So in this example, if we instead assume that the reduced scenes that are in the index comes from another video that matches the scenes, we will not know for sure if there might have been something different going on during the time of this yellow scene. Perhaps something has been blurred or cut from the video that makes it fall into another category, for example. Another, maybe not limitation, but uncertainty is that PDQ has not been battle tested to the same extent as PhotoDNA for our use case. So it's a widely adopted hash, but it hasn't been used as much by law enforcement as PhotoDNA has. It's a newer hash, and PhotoDNA has become a standard for image matching. So this comes with an amount of uncertainty on how it performs in the wild, so to speak. But in our test scenarios, it's working well with the PDQ hash. We also don't take audio into account. So if you have two files that have 100% overlap, they might still differ in the audio parts. So this is similar to how EXIF data might differ for images where the visual content is the same, but there might be other metadata that is different. And there's also, the behavior is also a bit different when it comes to false negatives for video hashing. So false negatives is when there are images or frames that the human eye would perceive as identical or matching, but the algorithm, for some reason or the other, doesn't mark them as being copies. So both PDQ and PhotoDNA has a threshold, and if the distance between the hashes is below the threshold, the frames are marked as copies. But if the distance is above the threshold, it would not be marked as copies. And where you set that threshold will determine how many false positives versus false negatives that you get. And as an example, if you would have a false negative rate of 5%, if we have an image, or if we do image matching, 95% of the images would still be correctly marked as visual copies, and those other 5% would have to be manually reviewed. If it is a video, the behavior would instead be that we would maybe get a 95% overlap between two matching videos. And even though the you and I might say that there is nothing that differs in the other 5%, if you don't understand how the matching is done behind the scenes, maybe this could be frustrating to an investigator that might wonder why 95% of the video matches perfectly, but there is 5% that aren't matched. But as much as it might be false negatives, there might also be something else going on in those 5% of the video. So we don't know that. Even if there's a 95% match, we can't assume that the other 5% probably match as well. It might be that something that actually has been modified there or cut from the video or so. So with these limitations, we can't make guarantees as to whether two matching videos will be exact copies or not. So therefore, auto-categorization is not something that we will be supporting at this time with the frame-based approach. I think there was a question here in the chat. Is the threshold configurable? No, it's not. The way we index the frames utilizes the threshold a lot. Depending on where you set the threshold, it can affect the speed of the matching. And we actually, the data structure where we store the hashes utilizes the exact threshold to make the matching as fast as possible. So that's not possible to configure. But if you see false, like a high amount of or false negatives, or if you see if you see false positives as well, of course, that would be very interesting to us, and then we could adjust that in the future, but we would have to adapt the index to that as well. Will you be able to see the matching percentage in Griffeye to get a better insight? Exactly how we visualize that hasn't been decided, but in some way, yes, we will need to show that. So we'll get onto a bit of that later. And yeah, I think we have talked about showing something in the file info panel, for example, indicating which videos, and maybe repurposing the visual copies header, the thumbnail header icon for video. But exactly how we will visualize matches is not completely done yet. So what happens if you have two copies, but the first video has first 10 seconds of empty video and the second is starting immediately? So the first is 10 seconds longer, but the same video. So we do a weighted score of the matching of the overlap, so to speak. So I could do some mathematics in my head, but I don't think I have the capacity for that right now. But basically that would be maybe a 75% overlap. It would be that video match would be marked as a 75% overlap because 100% of one video matched and 50% of the other. So it will be a weighted score between the two. A harmonic mean, to be precise, but I won't calculate that in my head right now. But maybe it answers the question anyway. Any other questions before I move on? In terms of hosting the video matching service, when we design the CS architecture now, we do not want to put more load on the main server. So therefore, the video matching service will be run as a separate service, preferably on a different host. And in the first release, it will be as a Docker container. So if you are running Griffeye Brain Server today, that will be familiar to you. There is no GPU acceleration here, though, so the setup is a bit easier. And containers can run on Linux, of course, but also on Windows by utilizing Windows Subsystem for Linux as the backend for Docker or Podman, for example. But we also plan on making it possible to run the video matching service as a Windows service natively on Windows. But this will not be included in the first release. So for the integration, the actual features to support your workflow, let's talk more about that now. We have a user group for robust video matching, which we sent out a survey to earlier this year, and most of the respondents brought up categorization of video as the part where they most benefit, where they see the most benefit of robust video matching. So while we don't support auto categorization, we would like to improve the categorization workflow as much as we can. And so one feature that we will add is in the workspace. If you have videos there loaded, it will be possible to filter on files with the video matches in the quick filter panel. Exactly which filters we will include here is not yet entirely decided. So if you have James Trainer seems to be happy with them, but if you have any feedback on which filters you would like to see here, yeah, that feedback will be very interesting. In the file search, we think that we can have a bit more of a dynamic filter when you search on the entire server. So you maybe want matches to specific categories, maybe focus on the illegal, for example, and being able to decide the amount of overlap that you're looking for. Maybe you want to start with those high overlapping matches to quickly categorize videos, but maybe if it was Dennis that mentioned in the chat, maybe we should have something here for when you have a match that is fully contained within another video as one of the overlapping options here. Could be something as well. And then you could load those all those videos to a workspace, and so that you can work on the categorization of those videos at the same time. When you have a specific video in a workspace that you're looking at, we will have support for searching in the workspace for the video matches that you have in the workspace already, and that would show up in the search results panel, similarly to when you do similar image search. But also an option to search across the entire server within the current case or across all data for all the video signature matches that you have there. And then, like for similar images, that would open up in a different workspace. If you use investigations, the feature where you can create a new investigated case from a number of files that are already in CS. Video matches for file that you add to the investigation will also be included. If you create a new investigation or add to an existing one, video matches will be included with that. So these are a few of the first features, and we would like to do more in the future, and there will be a bit more than what I've shown now, but we haven't don't have UI sketches for all of that yet, and we also want to release this to you as soon as possible as well. We have been working on this for a long time, and are really looking forward to get it into your hands and then get your feedback on what else you see that we can do with this, and when you start working with it. With that said, there's of course some future work that we have planned already and know of, and Git integration is the major part of that, of course, and supporting Windows natively as a Windows service is part of that work. And to take things step by step, we will first do that, and then we will support Git integration in CS, and then in the second step in DI. And with that comes, of course, including the signatures in the hash exports and stuff like that, so that you can import them to your GIDs. We also want to support video matching in file bounds, the feature that was added to the new web UI this year, so that when you are able to upload a video there and get a search result if there are video matches in CS. And yeah, we also want to allow you to set up alerts on specific videos so that you can get a notification if another matching video is imported later to CS. And we will continue to involve the user group for robust video matching. If you are not yet in the user group and would like to be, please reach out to me or anybody else at Griffeye, and we will include you in the future. If you got the survey earlier this year, you are already in the user group, but if you didn't, then you are not. And yeah, we like to get as much feedback as we can. So if you would like to be part of that, just reach out to us. Are there any other questions? Because that's all that I had for this presentation. Okay. If you do have any questions afterwards, you can also just reach out and yeah, let us know. We'll respond. Thank you.
Thank you, John. That is the wrap up for today. If you have any questions, yeah, just let us know and we'll answer them tomorrow. I also want to remind everyone about the form that Matthias talked about questions regarding the Griffeye and magnet integration. So please fill that out so we can have a summary about your questions tomorrow. Yeah, and we'll start 12 tomorrow as well. And I hope to see all of you then. Thank you for a great day.
Thanks,
Goodbye.
everyone. Bye-bye.